You know that box in your kitchen, the one that's always humming away 24/7? We all have one, but have you ever actually stopped and wondered what's really going on inside? Well, today, we're going to pull back the curtain and uncover the surprisingly clever science of how your refrigerator really works.
So, it seems like a pretty simple question, right? A fridge makes things cold. End of story. But the real answer is so much cooler. Pun intended. The secret isn't about what a fridge adds to the inside, it's all about what it takes away.
And boom, there it is. This one little idea changes everything. Your refrigerator isn't a cold-making machine, it's a heat-removing machine. Once you get that, the whole process just clicks into place.
So let's dive into this surprising secret. We're going to take a look at what it actually means for a machine to spend all day and all night just moving heat around your kitchen.
Okay, so here's the bottom line. A refrigerator is basically just a heat pump. Its entire job, its whole purpose in life, is to grab the heat from inside that insulated box and dump it out into the room. The cold that you feel, that's just what's left behind. It's the absence of heat.
And you know, it's actually a super relatable idea. Just think about sweating on a hot day. That moisture on your skin evaporates, and in the process, it pulls heat away from your body, cooling you down. Well, your fridge is doing pretty much the exact same thing, just in a sealed mechanical loop.
Now, to pull off this amazing heat-moving trick, the refrigerator depends on a team of 4 key parts, all working together in this perfect continuous cycle. So, let's meet the players.
All right, first up, you've got the compressor. That's the heart of the whole operation, the engine. Then you have the condenser coils. Those are the warm, radiator-like things on the back. Next, a tiny but absolutely critical part called the expansion valve. And finally, the evaporator coils. These are the real heroes, doing the work on the inside. But here's the thing. These parts are just the highway. The real star of this whole show is a special fluid called a refrigerant. This stuff is constantly circulating through all those components, magically changing from a gas to a liquid and back again. And it carries the heat with it on its journey.
Okay, so now let's actually follow a single drop of this refrigerant as it goes on its wild ride through the 4-step cooling cycle. This is where the real cleverness happens.
All right, here we go. First, the compressor does its thing. It squeezes the refrigerant gas. You know how a bike pump gets hot when you use it? Same idea. Compressing the gas packs its molecules together and makes it a really hot, high-pressure gas. Then, that hot gas travels to the condenser coils on the back of the fridge. There, it releases all its heat into your kitchen, cooling down just enough to turn into a liquid. Next up, and this part is amazing, that liquid gets forced through the tiny little expansion valve. As it shoots out the other side, the pressure just plummets. This super fast expansion needs energy, so the fluid literally steals that energy from itself, becoming intensely cold. And finally, this now super cold refrigerant flows through the evaporator coils inside the fridge, and it's like a sponge for heat, soaking it all up from your food. That heat absorption makes it boil back into a gas, and it heads back to the compressor to start the whole trip all over again.
And this isn't just a one-and-done deal. This brilliant loop just runs on repeat, constantly, day and night. The second the thermostat inside senses the temperature has gone up just a little bit, it kicks the compressor on, and the whole cycle starts again to yank that heat right out.
Have you ever wondered why the back of your fridge feels warm? Well, now you know. That's where the condenser coils are, releasing all the heat they just stole from inside. And at the exact same time, inside the fridge, the evaporator coils are busy absorbing heat, which is what makes the inside feel so cold. It's just a perfect, elegant exchange.
So, we've gone through all the physics, but why does any of this actually matter? Well, it all comes down to the food you put on the shelves. Let's talk about the real-world payoff of this whole clever process.
The science here is actually pretty simple, but so powerful. See, heat is energy, and for the tiny bacteria that make food go bad, a warm kitchen is like an all-you-can-eat buffet, where they can multiply like crazy. But by removing that heat, the cold environment inside the fridge slows everything way, way down. It slows down the bacteria, the chemical reactions, all the processes of decay. It's like putting food spoilage in super slow motion.
I mean, think about a carton of milk. If you leave it out on the counter, it's a goner in just a few hours. But inside the fridge, that same milk can last for a week, maybe more. That's not magic. That is the direct result of that cooling cycle we just walked through, constantly pulling heat away and protecting your food.
And hey, now that you're basically a refrigerator expert, you can help it work even better. The whole system needs air to circulate to pick up the heat, so try not to cram your shelves too full.
And, every time you stand there with the door open, you're letting all that warm air rush in, making the machine work way harder. Simple tips like these just help that brilliant cycle do its job more efficiently.
So, as we wrap this up, it really is incredible to think about this piece of smart science just humming away quietly in our homes, performing this complex thermal dance, second by second, all day long.
And that really is the main takeaway here. It's so easy to take for granted, but the simple act of keeping our food fresh and safe, it's a quiet triumph of engineering and physics. It's just a really clever solution to a really fundamental problem.
So the next time you open that door and grab a cold drink, maybe you'll take half a second to appreciate the incredible journey of heat that made it all possible. And that kind of leaves you with a final thought, right? What other everyday magic in your home is just clever science waiting to be explained?